Hey, are we on? Let's check. Go to over here. Yeah, no, maybe. Hey, are we on? Yeah, we are. Check. We on? Yeah, we are. Check. Here we go. Go to. Let's come over. Let's post this in a couple places. Um. I'll join this so I can hear people maybe. Is that a thing? I should put this over here too. Is there not like a Triton puzzles channel? All right. It'd be good to be able to hear people, so maybe they could just join in here if want to talk or whatever. And I might post on story too. I feel like there's a way to add chat that I don't remember right now. Let's put a link up on my story and just say like, hey, join my live while I write GPU kernels. And we'll add a link. Just copy this link, paste it here. And one more thing, let's add a emoji. Of a graph or something, I don't know. And let's make this a little more colorful, like this. Bam. All right. So premise of this is that I found these Triton puzzles with these graphics. I want to solve them and put my progress on GitHub and share my progress on YouTube. I also found this other repository called Triton Puzzles Lite, and it's the same puzzles, but it's formatted in a way that's going to be easier for me to put on GitHub because the original repository is actually a bit broken right now. Whereas this one, I can just run the script right here. I can say Triton interpret equals 1. This puts it in like a debugging mode that runs on CPU. And then I can run this script and it'll tell me the first test that's failing, which is in this case obviously the first one because I haven't solved any yet. And it'll sort of let me know how I'm doing as I go. I have a server that my friend Max let me use that has his 1660 Super on it, and so I can test it on a real GPU without having to worry about like logging into a cloud service since I don't have one myself. But yeah, let's try it out. Let's look at puzzle number 1. I think I'm gonna do it over here initially, and then like upload, just copy paste my solutions into the GitHub because this one has the visualizations integrated in it. So let's see, we have this demo showing how load works. I already started reading this stuff a bit, right? I think this visualization is a bit broken anyway, so yeah. Use this trick to read it a 2D array. Over mask. Alright. TL store function is quite similar. It will allow you to write a tensor. I've also already done quite a bit of Triton practice, which is why I feel ready to sort of tackle this whole series and not be fiddling around too much. So really what I'd like to achieve here to sort of just have a few more things that I've written in Triton, and also just see, hey, have I absorbed stuff from the tutorials well, or have I just kind of been copy pasting and not really absorbed much of it well? Let's see how that goes. You can only load in relatively small blocks at a time in Triton. To work with larger tensors, you need to use a program ID axis. Yep, I remember this. Alright, puzzle 1, constant add. Add a constant to a vector, uses one program ID axis. Block size B0 is always the same as vector x with length n0. So zi equals 10 plus xi for I equals 1 through n0. So we have def as spec. This is the spec that you should implement. Uses typing to define sizes. Return x plus 10. Transient range equals tl.arange 0 to b0. X equals tl.load x pointer plus range. Finish me. So if we run this, it should just not work, it seems like, right? Yeah. Results don't match. Yeah, it's false everywhere. Okay. So here, it should be pretty simple, right? We should just be able to say tl.store we should be able to add 10 to our pointer. Am I thinking about this dumb? We don't have to mask or anything. We do have to mask. We want to only add to points where we want to only add to points that are in our length b0. Well, so yeah, we have a pointer, value, mask. Yeah. So our pointer would be x pointer, and our value would be x plus 10. And lastly, well, let's just try this first. Let's see how this goes. Value argument cannot be block type if pointer argument is not a block. Actually, let's come back over here and look at our reference. We have z equals tail.store, z pointer plus range, 10, range less than 5. Yep. Let's come over here. X pointer, z pointer, add a constant to a vector, use one program ID axis, zi equals 10 plus xi for, oh, I'm supposed to store it in z. Okay. So, first of all, we want to store this in z. Well, I'm trying to shortcut stuff. Let's just do it all super explicit, right? Z is going to be tl.load x, our new x is going to be x plus 10. I think we could just write it like that if it broadcasts like in NumPy. And then we want to write this to z, so we would say z pointer we want to write new x, and let's see how that goes. Value argument cannot be block type if pointer argument is not a block. This might be something wrong with this, right? I should also have the stream chat open so I could read stuff. How do I do this again? I haven't done this in a minute. So really just not like a pop-out chat. Oh, do I need to actually go to the actual video? So really just not like a... Here we go. Pop-out chat. And this right here. Copy URL of the chat pop-out window. Just copy this. Oh, what's up, Israel? You would use AI? I mean, I need to learn to use AI a bit more than I have been, but I really want to actually have this absorbed like in my head, you know? So I'm gonna try to use AI pretty minimally. I might use it a little bit just to avoid typing so much, but need to actually be able to do stuff. Let's put this in my OBS stream over here. Pretty sure I can add a browser source like this. Yep. Okay. And the URL will be this. Okay. See how that goes. Yeah. See chat right here. But is there not a way for me to sort of like be able to see what is being said in chat while I work on stuff? I guess I could just sort of have it on the side. It's a little annoying. How you doing, Israel? Close. Over here. I'm gonna try making this edit over here and sort of see if it complains in the same way, right? So like right here, I have puzzle 1 somewhere, constant add, like this. So let me try the same thing I did before, right? X new equals x plus 10. I know, like that. And then tl.store, we want to store our z pointer, and we want to put in x new, like that. And let's see what happens when I run this script. Let's see what Israel says. Chilling and watching you while I'm on break at work. That's what's up. Thank you, sir. Pointer and value. Ah, I see. So I'm putting in a pointer here, and really I should be writing to each address, right? So I should probably be saying like, I should be adding these offsets like this. And let's see. Results match false, but we didn't get our error from before. So like over here, let's try that over here too, right? But that means it's not messed up, so I'll actually just stay over here for now. I'm gonna make this a little smaller. Yeah. So it's called it's called a range over here. Hey, results match true. Yeah. Did it just do the thing? Okay. I think we did first puzzle. That was like stupid easy. There has to be what's messed up over here. It's off X. Yeah. Finish me. See also Z pointer. I didn't even use N0. I wonder what I did wrong here. Let's try it. Let's try just running it one more time. Because it looks almost the same, right? I have my range from 0 to B0. This sort of like, if you're familiar with pointer arithmetic in C, our X pointer is sort of the address to the beginning of our array, and then our A range lets us look at all the indices from 0 to whatever number that we look at and write to them versus only writing to the first address, which is our X pointer, right? So right here we have our offsets from 0 to B0. This is the block that we want to write to. And then X tells us where the beginning of the blocks is, the X pointer. And so we load from the beginning all the way through each value in the block that we added here. We write that into X. Then I add 10 to each element in X new. Python kind of just knows to broadcast this across the whole vector because we wrote this into like a NumPy array. It might not be a true NumPy array when you're actually like working in Triton, but it has the same semantics. And then when I'm storing here, this should be doing the same thing. Z pointer is beginning of the Z beginning address of the z pointer array. Off x tells it all of the elements to write to in the block, and then x new is the value that we're writing to each value. Maybe that returns them? No. I don't really understand why it's like, I hope this isn't broken or something. But yeah. A little weird. Why it's not. I don't know if I want to spend too much time. No, I do want to spend time debugging because I want to post this to my GitHub. So let's see if there's something really simple here that's going wrong or not. So let's see, mine's is I wonder if it's even getting like written to properly. I don't care about this comment. I'm gonna delete that. Let's just copy paste what we have over here, so that way we can tell that there's nothing like really stupid, like there's nothing really stupid making it break. Yeah, I wonder what's up with this. This is like not even. It might be something with this. I was hoping this would just work pretty well so I could like publish my stuff on GitHub easily. It's probably a bit annoying that I'm debugging on stream, but whatever. Mine is 0.037. This kind of just looks like Z isn't even getting touched at all, like in the test, but I can't tell if that's my fault or not. Because it's not even like something consistent with the inputs, right? Let's go to test over here. Oh, the whole point of having the interpreter is to make it easier to see intermediate values, right? So let's just try printing x and new x and see what it says there. Yeah, so these are all basically almost 0, right? And then these are coming out to 10. It's a little strange. Shouldn't there be at least a little something? Well, I guess not if they're like tiny. So maybe it's this. It's not loading in the stuff properly, it's just getting all zeros. Because check this out, right? We should even be able to say like load z pointer plus range and put this into z and print z and see that it loaded properly. Z is full of these 10s too. So it looks like x isn't even getting, but it's weird because the test isn't getting that. So I think this test is just broken and I might fix that another time. we will just continue on the other thing because I want to make some progress today. So we did puzzle 1, puzzle 2, constant add block. Add a constant to a vector. Agatha, it is your fault. Damn. L. What up, Agatha? How you doing? Add a constant to a vector. Uses one program block axis. No for loops yet. Block size b0 is now smaller than the shape vector x, which is n0. Oh, so we want the same thing, but we want to do it in blocks. Bryce, your test is broken. It's not my test, Bryce. But yeah, it's broken. Add mask to kernel. Test add mask to kernel. All this stuff. Alright, I think this one's actually pretty easy, right? Let's say we have our x pointer. First we want to look at our offsets, which is going to be tl.arange 0 to b0, like that. Why did it do that? Stop. And then x is going to be our tl.load x pointer plus offsets. How do I turn AI off? Is that possible? I didn't know you could like put emotes like that in the chat. AI assistance. Close. There we go. Alright. So we have our offsets. Vibe coded. Nah, we're not vibe coding it, Bryce. I'll vibe code it on the actual job. Actually, what's crazy is in that research program I've been doing, I got Gemini to vibe code like literally my entire idea and implementation. I like didn't write a single line of code. It was kind of crazy. Kind of blew my mind a bit. All right, so now we have our x. Print x, and basically I'm gonna rewrite what I had before, but there's gonna be a difference here, which is essentially. So actually maybe that's just what I should do. I'll copy paste it first. Like this. I like the name offsets better than range. I don't want to shadow range from the global namespace. So we're gonna go like that. So this is gonna break. The reason this is gonna break is because n0 is b0 is too small to write to the whole thing. So this is gonna kind of mess up, right? Yeah, results match equals false. So what we need to do is we need to get PID from Triton. We can say like tl dot, I think it's program ID. Yeah, and we're just gonna say 0 because we're working with a 1D array. And then instead of loading in x, we're gonna load in a block of x. And so I don't know how I should name this. Maybe I should just say like basically what I want is this to be shifted up however many blocks up we are, right? Like this. So if I'm on thread 0, then I'll add, oh, I did this a bit wrong. X pointer plus, I want PID times B0, I think like that. So maybe I should name this like block pointer or something, right? Like, and then I'll just load in my block. And I'll say this is my X block. And then my new X block is X block plus 10, like this. And now instead of storing this to Z, we want to write in a block of Z. So we're gonna sort of jump ahead just like we did for so I'm gonna call this X block pointer, right? And then for my Z block pointer, I'll do the same thing. I have Z pointer plus PID times B0, and then my Z block pointer I'll write in my new X block like this. I think I might have done this right. Hopefully. Yeah, no. I mean, it all says true. Looks good. Is there a way I could have wrote this a little less like jank, maybe? Let's see. No, I think that's pretty clear. And that looks right to me. Looks right-ish. Let's try copy pasting this into other tests, see if it works. Well, no, it won't. Yeah, just leave it. I'm a bit concerned about like the N0 part. I haven't been using them, right? But really, like, if I'm loading in blocks, I should not, if the offsets exceed the length of the vector, I should be masking them out instead of writing to them. But I think they've sort of chosen values where it doesn't matter too much. Yeah, block size B0 is the same as vector x with length N0. So in this case, we don't need to care about mask. But even here, okay, B0 is now smaller than the shape. Ah, yeah, there's an invalid access. So I need to add the mask. So what we're gonna do here is when we store, we're gonna add a mask. And what is the mask? Our mask is that we need what do we need? We need something to be less than N0. But what needs to be less than N0? The indices that we're writing to in the Z block pointer. But will we just write it like this? I'm not sure. Let's try it. Yeah, that's not right. Let's look back at the mask example. Right here, range less than 5. No, it's not that. It's not that either. Okay, so right over here, when we're loading, we need this to be less than N0. So I'm gonna put Z mask right here, like this. I don't know. Mask equals X block. Less than N0. I'm gonna put this mask in. Like this. And delete this. See how that goes. I feel like I'm like messing up the how you actually write it. Yeah, we got range. Less than 20. Oh, I see. This should only be being applied to the offsets and not the actual, the offsets correspond to indices, right? So, like right here, really what I should be thinking about here is like, this should be like right here. This corresponds to our indices that we care about. And then offsets right here, I'll compare. And I don't worry about the start of the X pointer. Right, sort of like if I had an array in C, I only want to check the indices that they are within bounds, and I wouldn't actually like add the physical address or the virtual address of the array to the index before checking whether it's in bounds. So this right here should work fine, right? Offsets less than 0 should work in both places. And then I need to edit this a little bit, right? I need to say X block is, so let's call this like block offsets. Maybe that's a little more accurate. Put this here. Then I could just put X pointer plus block offsets equals X block, and new X block is X block plus 10. And then we want to store Z pointer plus block offsets is this. See, results match true. And this time, since we use the mask, there should be no invalid writes. Yeah. Great. So that's second puzzle done. Puzzle 3 is outer vector add. We add 2 vectors, and we use one program block access. We want a block size B0, which is the same as vector X, so it's kind of like in the original one. Block size B1 is always the same as vector Y, length N1, and Z Ji equals Xi plus Yj for I equals 1 from B0, J equals 1 to B1. Ooh, this is strange. Outer vector add. So basically we're gonna like add a new axis. I'd sort of like to see like an example of this. Like I don't know. Can we let's print np dot our array of 1, 2, and or let's do torch out tensor, right? Torch out tensor 1, 2, and torch out tensor of 3, 4. Oh, well, I need to actually pass it into the thing, right? So let's say x equals this, y equals this, and then let's print add vec spec of x and y and see what the outer product actually looks, the outer sum actually looks like. We have 4, 5, 5, 6. It's confusing me a little, I won't lie. 7, 13. Oh, so we have 7 plus 3. We have 13 plus 3. 7 plus 4. 13 plus 4. What? 13 plus 4. Oh, it's sort of like a dot product, like a matrix product, but we're doing sums instead, right? So I turned this into a column vector, right? I have my 7 and I have my 7 and my 13, and I have my 3 and my 4, and I take the sums in each pair, right? So it's like I have 10, 16, 11, 17, like that. Cool. So over here, what do I want to do? First, I want to load in these. Actually, is the product of the blocks too big to load in all at the same time into SRAM? We'll see. So let's try x offsets equals TL.A range 0 to B0, and y offsets equals TL.A range 0 B1, and we don't have to worry about masks because we were guaranteed the size would be the same as that of the vector. So let's just load. We'll say x equals TL.load x pointer plus x offsets, and similarly for y, we'll say y equals TL.load y pointer plus y offsets. Then we will do this sort of sum right here, and this will be our outer sum, like this. And then we need to write, so we'll say TL.store z pointer plus, let's look back at the 2D write example code. I think we're going to have to do some like weird slicing stuff, right? Like this right here. Yeah. So why are they doing the times 4 here, right? We have our I range, A range right here. Let's print I range. Print J range. And let's print let's print range after and see what it looks like. So I range looks sort of how I'd expect. It's like a column vector and row vector. I might have said it backwards. And then right here, we multiply by 4. And we add j range. Let's print their sum and just see what happens. What's I range plus j range? It's this outer sum. What's I range times 4 look like? Yeah, that's sort of what I figured. Alright. Let's come back to where we were. And over here, what we need to do is we need to write our offsets with our outer sum. And these z offsets are gonna be a little wonky, right? We need x offsets. We need to expand it like this. And then we need our y offsets, and we need to expand it like this. We need to add new axes. So I think this should work fine like this. Give it a shot. Nope. Wonder what went wrong though. We'll see. Might just be the block size. Yeah, like let's try putting B0 here. Ta-da! We did it. Did 3. Yo, I'm like blasting through these. I want to understand this a little bit better though before I move on, right? What is this really doing? So let's look at our let's go back to where we were before, up here. And let's really try to like understand what's going on here, right? Tell that A range should just give us an array full from 0 to 7. And this none should sort of add a new axis, and it should be the second axis. So each element should get sort of encased in a list, whereas this one adds a new axis, but it's in the first dimension, so it should simply encase my whole list in axes, in brackets versus each element, right? Is that sort of what happens? Yeah. So when we multiply by 4, it should just be multiplying each element by 4, right? Yeah. So I'm a little bit confused on why this works properly, right? So when I'm adding these together, I'm getting my sort of outer sum, which was sort of like that dot product we described. Why do I want it to be a block ahead? Mm. Oh, I see why. It's because so if we imagine Z being stored in memory, uh, flatly, or like if we are using a stride, right? What we want is to basically this is a shorthand for this, right? So if we you can flatten a 2D array by sort of saying, hey, look, if it's a m by n array, instead of saying um, instead of saying array of I j, if we're storing it in like a 2D fashion, or if we're sort of manipulating it with strides, we could look at a of I times m plus j, like this, right? So essentially, if the if the tensor that we're looking at um, has like is being manipulated with strides and isn't actually a 2D array, we would the start of the next row in our Z would be after m elements. So we want to make sure, hey, when we write the first element in our second row, it's after, b0 uh, elements that came before it. And I think that's why this worked properly. Um, so now I think we're doing the same thing, but we need to use masks, right? Let's see. Add a row vector to a column vector. Uses two program block axes. Oh no, it's a little different. Block size b0 is always less than the vector x, length n0. Block b1 is always less than the vector y, length n1. Oh no, I think it is the same, just with blocks, right? So now I have my PID 0, PID 1. So what exactly am I parallelizing across here? Naive thing would sort of be to parallelize across each element, but that might be a bit slow, right? Well, let's try what we had earlier. PID 0, PID 1. Should have a whiteboard for this, right? I don't care. Just give me a thing, please. Please give me a thing. Yeah. So what I'm thinking is like, all right, got vector 1, this is x or whatever, got my y, and I'm going to be looking at sort of like a block of each. So I should probably like flip this so it's a little easier for me to think about, right? And I'm going to be adding these sort of like in a in a dot product fashion, and I'm going to be looking at a block, right? So let's say we were looking at this block right here, and we were going to look at this block right here, and they might be different sizes, B0 and B1, right? That's going to correspond to me writing this part of the Z pointer array, right? So I can sort of maybe draw that out as a shape as well. I think grabbing these parts will be easy enough, and then I just need to think about, hey, where am I actually writing to? in my Z array, and it seems like I could sort of get that from my offsets. I could sort of use the same rule I just mentioned before. So let's try that. Let's try getting our arrays, our array, loading in our array chunks, and using our PIDs to sort of jump ahead however many rows or columns we need to. So first I'm gonna say x equals x block equals um, now let's do this differently. Let's say x let's do it like this. X offsets equals TL dot A range 0 be 0, and our Y offsets are 0 be 1. X equals TL dot load when they do the mask, when I do the mask, I only need to worry about it for so when I do the load, I'm gonna say X pointer plus, let's see, I'm not sure if I should put it in here yet. I'm gonna just try putting it in here, and then we could fix it later if it's not, right? So like PID 0 times B0 would be how much we need to sort of jump ahead if we're on a block, right? So 0th block, we jump ahead 0. 1th block, we jump ahead 1 block worth of space, so on. Same thing over here, but on the other axis. And so if I did this correctly, we should see x offsets like this, and then our mask would be x offsets needs to be less than n0, right? Needs to be less than the length of x. Otherwise, we're gonna be reading in memory that we shouldn't. Same thing for y. We load in our y pointer with our y offsets, but we need to make sure that our y offsets aren't reading past the end of the y array. And so, I don't know, maybe let's just try printing x and y. See if that like works properly. What the hell has happened? Why is there so much? Wait, get rid of this. Are the vectors 2D? Oh, like this right here. Yeah. So we have our x, we have our y. It looks right-ish to me. Hopefully. Maybe. So now we want to only write to a certain part of Z. only that block from our whiteboard right here. So how do we actually get that spot? Well, first of all, we kind of need to do what we did before, right? We need to sort of take this we need to make our z offsets, which should be our x offsets. Oh, how did I do this before? Our x offsets are turned into a column vector plus our y offsets, which should also have a new axis, but the other way around. And then, you know, like if I wanted to just turn my brain off, I would just say tl.store. So what was our outer product again? Our z block equals this, right? And then we hold on. Is there a way for me to pause this? So if I were to sort of do this naively, I would say, let's just take our z pointer, add our z offsets, and then make sure our mask says that, says what? We need, what do we need? We sort of need both of these. There has to be like a better way to say that though, right? Yeah, we sort of put this and right here. I see. So what we're gonna need is we're gonna need like a z mask, and basically we're gonna say x offsets needs to be less than n0, and y offsets needs to be less than n1. And then each of these needs to get expanded properly, right? And then over here I can just say, let's call this outer sum. No, sorry. Then we'll say mask equals. Am I doing this in the wrong place? I think I'm doing this in the wrong place. Yeah, this should be down here. Yep, so z block right here. And then mask equals z mask, where z mask equals x offsets less than n0 and y offsets less than n1. Each of these needs to get like expanded. So this one should probably be like this, and this one should be like this. I'm still not confident this is gonna work properly, but we're gonna just try it. No invalid axes though. So I'm probably just not writing things correctly or like adding things together correctly. Yeah. So let's look. I think it has to do with this, right? I wonder if this is just if it's just as simple as that. Hmm. So let's zoom in on this a little bit, right? What's actually going to be happening here? So if this is x, then this is length b0, and this would be length b1, which means that wherever we start here, we're going to be writing in b0 elements b1 times. Sort of whatever, like this, right? In terms of what this start actually is, what is this? This is going to be PID times B0. This is going to be PID times B1. And then this would be, okay. So this needs to start at PID times B0 and go up to and go up one by one until we get to PID times plus 1 times B0 and so on. So, oh man, what is this gonna look like? I think the problem is with this, it's essentially like when we do this combination, we need one of these to just be the offsets without the without the right, like when I'm needing this to go one by one each time, well then that means that there shouldn't be any PID thing on it, right? So like what if I got rid of this and then I put it over here and over here? Well, still false, but might do the same thing right here. Yeah, like actually, I might say like this, right? I'd say x block equals x pointer plus PID 0 times B 0, and then I would just load in the x block pointer plus the x offsets. Or let's simplify this a little bit. X blocks. No, I think x blocks pointer is fine. I think I'm overcomplicating this a bit. Split this right here, and this right here. Plus plus. Get rid of this. Just like that. Okay. Just like this. So now we have our outer sum. This part is the part that's a little like, what's happening? Like this looks right, but I need it to start. I think what's happening is that it's not in the right place, right? So I think I have this rectangle, but it's like not where it should be in terms of like the left direction and right direction, right? So I sort of just always have this block up here. But so I just need to think about how I need to how I can move this to the correct position.
Hey, Lisa, calm down. Yeah, please. This is not sick.
Can you give respect to? Oh, I've been bro, please.
Okay.
This is no sleeping.
Alright, please.
You black and black. Harder.
I understand.
Wait, wait.
So,
You,
please.
wait, you black and black. I'm not. I'm listening to people calling the phone.
I
I'm not listening to
understand.
nothing.
I
Can
don't
you
want
give the
to
respect
smoke.
to people?
Yes.
You're the daddy.
No smoking beer.
Yeah.
I'm not sitting on this place.
Okay, okay. They
Thank
told
you.
you need please.
What's your name?
So do you respect it? So if you don't respect me, if no money, I'm giving the respect.
Alright.
Yeah, I'm Muslim, they give the respect. Muslim,
Alright,
they
sure.
everything give the respect.
Okay.
In black and black. In black and black. I'm
Thank you.
Thank you.
How you doing?
I'm doing all right.
Anytime you see people like this coming out to smoke in front there, tell them to walk out. To keep walking, okay? Thanks.
This is let's do it with a smaller example. I think it'll help. So what I'm gonna do right here is I'm gonna say, let's say my b0 equals 2 and b1 equals 4, and then let's say my I is how do I do this smaller? B0 equals 2, B1 equals 4. Let's say torch dot range 0 to B0 is my, I don't know, let's just call this X. Y equals torch dot range 0 to B1. Then we could print this. Now 0, 1, 2, 3. Oh, this should be B1, shouldn't it? But why? So I'd have 2 rows, 4 columns. Yeah, this makes sense. Then I would say, let's print this. So we have 0, 1, and 0, 1, 2, 3. So for each row, maybe I'm thinking about X and Y backwards. This is supposed to be 0 and this is supposed to be B1. Right, because another thing is just like, I don't know, let's say we're on P1 equals 2 and, or P1 equals 4 and P2 equals 7. Then now we want this to start at 4, 7. Am I thinking about this wrong? 0, 1, 2, 3, 4, 5, 6, 7. That makes sense. Why is this B1? Oh, I see why. Because we're doing B1 each time. But why did that not mess up before? Like over here? Well, let's just try what we had before, right? Let's just try putting this, get rid of this, get rid of this, get rid of this, get rid of this. Alright, so now over here, let's just say we were at like +2 and +7. What would this look like? So it makes sense that this would start at 2, 3. This would go to 7, 8, 9, 10. That makes sense. It also makes sense right here. We have. Ooh, wait, why do we have 15? Yeah, we have 15, 16, 17, 18, 19, 20, 21, 22. This makes sense, I think. It's not quite what we want. We want this to also skip all of these, right? So I need this to basically be the entire. I need this to be the entirety of N1, I think, like this. So in this case, instead of B1, we might say, let's put, I don't know, let's put like 8